Okay, let's begin with question number 3. Okay, let's move it to a whiteboard, please. Okay, they're saying find the first 3 terms. First 3 terms in the expansion of in ascending powers of x of 2 minus x to the power of 5. So the concept to use, must always understand the concept first. So please take note, the concept to use is called the binomial theorem. One of the great discoveries. Okay. And so the binomial theorem basically is like x plus y to the power of n. So you all may know that this is x to the power n, and then n choose 1 generally. So maybe I won't use the x every time. I forget that. I have to use a different letter if they use x already. AB to the power of n, but it's okay. Just get used to the various letters. It'll be easy to think. N choose 1 of a to the power of n minus 1 decreased by 1. The b increased by 1 like that in order. So now n choose 2. The a decreased by 1 more, and then b increased by 1, blah, 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 until like n choose n minus 1. So this will be a, and then b follows the power of the b, if you notice, then b to the power of n. So as a shorthand, sometimes they write this as the sum of like a to the power of r. When you want to parameterize it, let me write the coefficient first. The n choose r is the binomial coefficient. So it doesn't matter, you can write a few styles. So I'm just trying to keep it to the one I wrote there. So b to the power of r like that. So r is running from 0 all the way to n. The first and last terms kind of simplifies to just a to the power of n and b to the power of n respectively. So this is the idea for this kind of questions. I must know the binomial theorem. Okay, likewise, so they say find the first 3 terms. So the first 3 terms seems a bit ambiguous, because how do we know it's like starting from x to the power of 0 or x to the power of 5? So usually it starts from 0, or by the order in which they write itself, we can see. That means wrote the constant first. That means 2 minus x, that means very accurate here, is equals to, using the binomial theorem above, with the value of a substituted as 2, and the value of b as negative x. Please take note, it takes the sign with it, and n equals to 5. So if you want to use the formula style, because I realize some students, they're more used to formulas. If you write a formula, then they feel more comfortable. So it's okay. So either way, so I'll use the formula also right here. I mean, the first 3 terms in that order that is specified would be like this. Okay, let's just substitute it first. So the a is 2, and the n is 5, so 2 to the power of 5. And then this is, it's okay. Do slow also okay, fast also okay. Depends on the speed. And this thing, there's no hurry as long as the accuracy is important. The accuracy, let's take note. So, and then this will be just 5 choose 2, a to the power of 5 minus 2, and then, sorry. Why am I writing a? I'm supposed to write the value, right? Writing a and x and all that. Sorry, but the a is supposed to be 2 first, x is okay. That means 2 to the power of, 2 to the power of 5 minus 1. And then, the power divided the power, right, smaller. Okay, 5 minus 1. The b is just a negative x. And then this is 5 choose 2. This is 2 to the power of 5 minus 2. I'm just substituting like a formula style. And then the b is negative x squared. So up to the first 3 terms. So we don't need to elaborate further. Let's just try like once first 3 terms. And if you didn't, it's okay. So here then we just simplify as normal. 2 to the power of 5 is 32. Just 5 choose 1. Please put in the calculator. What is 5 choose 1? 5 choose 1 is just 5 likely. Okay, 5, this is 2 to the power of 4. I'm just writing it so that it's a bit easier sometimes. You may need some times these details. So 5c2, as you can see, put in the calculator, is 10. This is 2 to the power of 3. And this is just purely x squared. Doesn't matter, the negative cancelled off. Okay, now we just simplify this. We should get readily the answer. So 32 plus, minus, plus minus there, sorry. Almost missed that, 80x. And then this also coincidentally is just 80 and then x squared. So these are the first 3 terms of the binomial expansion. The A part is done. Okay, let's go for the B part, please. So this is the first part. Now the not really B, second Roman numeral there. Hence, find the value of the constant k for which the coefficient of x in this expansion is -8. Okay, let's look at the expansion. So ak plus x like that. 2 minus x to the power 5. They say the coefficient term is going to be -8. So how do we determine this? If you notice carefully, there'll be always this kind of coincidences where this thing, the green arrow is pointing, please take note, is the same. 2 minus x to the power 5. Oh, that is kind of useful, I think, because then we can rewrite this under the perspective of k plus x like that. And the second one in the bracket, we'll write this in the bracket as the first three terms, copying it from this line, the one we found. Normally it'll be linked like that. Please take note. Minus 80x plus 80x squared, then plus blah, blah, blah. But the blah, blah, blah is not just any random term. It's powers of x with 3 and above. So imagine you want to get x. So we can do this with a bit of reasoning instead of memorizing a technique. So the one with the x will be like this times this. So select out, in other words, all possibilities for the terms which form x, which has exactly x only. That means the power of x is 1. So as the arrow indicates, one of the ways to get from there is k times with -80x. And then if the k, if you notice k times with anything else in the bracket, like 32 means it's a constant. If it times with the 80x squared, it has a power of x at least 2. So no more with the k. So from the x, similarly, the only way to get a term is multiply by 32 plus 32x. Because if x here, from the first bracket, multiply with x in the second bracket, like -80x, it becomes an x squared. If it multiply with the x squared term, 80x squared, it has an x cubed term, and so on. So that means the powers of x are always greater. So the only way to get exactly the power of x are only these two terms, from which now we factorize. We'll just rewrite this 32 minus 80k with an x. But since this term is not given, but only the coefficient means only talking about this, the front part, from here until here, ignoring the x, meaning that now we equate that and solve. So 32 minus 80k equals to -8. Oh, so 80k equals to 40. 32 plus 8 lah. All this you'll know, So let's divide it, please. So this one, divide like that, and finally we arrive at the value of k, which is half. That's the answer for this. So it's the answer for the second part, and this was the answer for the first part. We're going to put it in the box, all right? If subjective. Thank you.